let us solve a linear congruence of this one. 84x congruent to 69 in mode 1200. Alright, normally the question that's given to you will be a large number that will have number that is, we are looking for the solution for x large enough to have GCD with the mode. In this case, I let you find the GCD with the method that you know. Normally just using the repeated calculation of remainder. The GCD in this case is 12. So we can actually reduce. That should be your first step. You can reduce 84 and the congruence, because if the congruence has a solution, the GCD should divide the congruence. In this case, 96 can be divided by 12. So you should have solution for x. And also, since the GCD involve mode as well, we can divide all three numbers with 12. That normally should be the case when you are given this kind of linear congruence. So 84 divided by 12 is 7. We have 7x congruence to 96 divided by 12. 8 mod 1200 divided by 12 is 100. So we are looking for the value of x. And there will be 12 solution, and the separation between the solution will be 100. So we can use Euclid's algorithm in this case also, but then we need to reduce 8 to 1. Knowing the inverse in that case, what case? In this case, 7d congruence to 1 mod 100. Alright, solve for d, then you can just multiply by 8 to get the value of x. Alright, so we use Euclid's algorithm decomposition. We get 100 equal to some multiplication of 7, which is in this case 100 divided by 7, which is 14. Okay, 14 multiplied with 7. So we should get a remainder of 2. Then next is 7 in terms of 2, meaning 7 divided by 2, which is 3, multiplied by 2. The remainder is 1. So when we get 1, we know that we can get the inverse of 7, which is d in this case. Then the reverse substitution or reverse replacement is, again, we put 3 multiplied by 2 to the right, and everything on right swap to the left, and 1 is on the right. 1 equal to 7, subtract with 3 to the power 3 multiplied by 2, and 2 we want to replace with 100 because 2 is congruent to 100 in mode 7. But we need to have a number that is multiplied when we multiply with 7, we still get a 1 if we subtract with 3 multiplied by 100. Remember, 100 is the 2 replaced by 100 in this modular equation that is written as a regular equation, but this is modular, meaning 100 is identical to 2 or congruous to 2. 2 can be replaced with 100 in mode 7. So 300, of course, plus 1, and then divide by 7, we get 43. So the equation still holds. 1 is equal to 43 multiplied by 7 minus 3 multiplied by 100. So then apply mode 100. This part becomes 0. So 1 is congruent to 47 43 multiplied by 7 mod 100, and in this case the inverse of 7 is 43. The inverse of 7 is 43 mod 100. Just check. 43 multiplied by 7 is 301. Mod 100 of course is 1. So now we know that D is 43 in this case. To get a remainder of 8, we just multiply this side, both sides with 8. So from 7D congruence to 1 mod 100, we get 7 multiplied by 43 congruence to 1. 43 is the inverse mod 100. To get a remainder of 8, we multiply both sides with 8. So congruent to 8 in mod 100. In that case, x is 43 multiplied by 8. X is congruent to 43 multiplied by 8. Congruence to 344. This in mod 100 is 44. Alright. Mod 100. And that is it. X is 44. Then you have to convert back to mod 1200. But the first solution is already correct. Alright, you can check. 84 multiplied by 44. I want to save some time. In this case, mod 1200 is 96. But then you need to give 12 solution. Why? Because the GCD is 12. You just need to add 100 to 44. So x now is not equal, but now is not congruent, is equal to 44, or we should put congruent to 44 and 144, 244, 344. You add 100. You need 12 solution because GCD is 12. 444, 544. For this case, the solution looks very simple because the separation is 100. 644, 744, 844, 944, 1044, 101144, and that is it. 4, 8, 12. Okay, this is in mode 1200. That is the solution.